Hello, everyone, and welcome back to our discussion about circle as a conic section. So, before we proceed to the topic for today, which is graphing a circle, let's have a recall. Like, what have we learned so far? So far, we know the definition of circle as a conic section. So, here, we know that circle is a type of conic section where all endpoints are equidistant to the center. So, for example, you see this R, which is the radius, okay? So here, let's just say the length of the radius, or basically the distance between the center and a given endpoint, which is here, let's just say it's 3 units long. So in that case, okay, if ever I'm going to draw another radius, suppose it's here, okay, here, then the length would be also 3 units long, okay? From here to there, the length would be also 3 units long. All right. That is basically circle in a nutshell. All right. Another thing that we've also learned is about general form to standard form conversion and standard form to general form conversion. In fact, we actually have a 1 hour practice for that. So here, let's focus on the part that I talk about general form to standard form conversion. I think I stated two reasons there. But let me only state one reason, which is related to what we're doing today. All right. So, one of the main reasons why we need to learn how to convert a general form of the circle into its standard form is because it is very useful in graphing. All right. And why is it very useful? Because the standard form describes the location and description of the circle. Actually, maybe that's actually a wrong grammar, but basically it tells you the location and the description of the circle. Okay, it's tell. Okay, maybe I'm wrong here. Not describes, but rather tells. Okay, tells. Tells the location and the description of the circle. And I added an information here that standard form will also exactly tell you whether the given general formula of circle is a circle or not. Huh? Like, what do you mean? Like, it's a general formula of a circle, or general form. Okay, general formula or general form, they're just the same. But yeah, the given general form of a circle, if you're going to convert it into standard form, is still a circle. You know, general formula of a circle is a circle. Nothing more, nothing less, right? But according here, I said that if we know the standard form, it will also tells us whether the given general form is double quotation, circle, or not. Why though? Like why there is a distinction? Let's have a recall. Do you remember the time that we actually discussed about general identification of conic sections? It's one of the introductory topics of conic section. Like, generally speaking, how would you know if this is a circle, parabola, ellipse, or hyperbola? Do you remember that? All right. And at the same time, we also learned that how would you know that it really is not a conic section? So let me give an example. All right. Let's just say I have x squared minus 2y squared plus x minus 6y is equal to 0. So you see this formula, okay? This is a general formula of a conic section, okay? Now that I mentioned that it is a conic section, what type of conic section is this? Is this circle, ellipse, parabola, or hyperbola, generally speaking? So if you haven't, if you like, you need a recall, I suggest you should watch the video. I'm gonna put it on the description. All right. It's basically connect sections, general identification. All right. Or let's just say you do not know that. I suggest you should watch it. Okay. So yeah, how would you know? Generally speaking. So the answer for that is hyperbola. How do I know if it's hyperbola? It's simple. Look at the coefficients of x squared and y squared. The coefficient of x squared is 1. The coefficient of y squared is negative 2. They're not the same in terms of numbers, but not only that, but it's also the signs. The signs are opposite. X squared is positive, y squared is negative. So if the coefficients are not the same because of their signs, regardless if the numbers are the same or not, then it is hyperbola. All right? It is hyperbola. Now let me give you another formula. Let's just say I have this one. X squared plus y squared plus 1 is equal to 0. This one. What type of conic section is this, generally speaking? So this one is actually a circle. How do I know that it's a circle? You will know it's a circle if, again, the coefficients of x squared and y squared are the same. Okay? It's obvious because take a look. All right? The coefficient of x squared is 1, which is the same as the y squareds, which is it's 1. So since they're the same, we can generally conclude that it's a circle or generally identify that it's a circle, you know? So if that is a circle, now let's convert it into standard form. Okay, it's easy because in this case, we have x squared, y squared, right? And then we have a constant term. So if you remember last time, if you see x squared, y squared, and a constant term, okay, we will apply first case, which is first, you group the term that have variables, which is basically x squared and y squared. Just leave them be. So x squared plus y squared. Then the constant term will be put on the other side. So from positive 1, transpose it here, will become negative 1. And this is the standard form. Now, here's the thing. This is a standard form for x squared plus y squared plus 1. So, is it still a circle? For you, you may be thinking, yes, because overall, you have a general formula, you convert it to standard form, it's a circle. But in reality, that is not a circle. That is not a circle. How? How do I know that it is not a circle, despite the fact that we know that if we see these, as long as the coefficients of x squared and y squared are the same, it's a circle, right? So in that case, if the general formula is circle, why is it that the standard form is not circle? you know? And because I said that it's not a circle, therefore this formula right here, this one, x squared plus y squared plus 1, this will not be circle anymore. All right? According to the standard form, it's not a circle. Therefore, this general formula is not circle as well. So how do I know that it's not a circle? Look at your r squared, right? Suppose we have the standard formula. We have this one. You remember this, right? The standard formula. The r squared. R squared is basically the constant term on the right. Okay. Take a look. If your r squared is equal to 0, then that is the point. Point. That's it. All right. If your r squared is less than 0, then that is an imaginary circle. Therefore, take a look this one, okay? Like, I'm gonna write it here again. X squared plus y squared is equal to negative 1. Therefore, if you're going to take a look, r squared is again on the right side of the equation, which is the constant term. R squared is equal to negative 1. Now, you see, negative 1 is less than 0. Therefore, we conclude that it's an imaginary circle. I mean, yeah, it is a circle, but it's imaginary. All right. Now, here's a question. Why is it imaginary circle? And if your 0 is r squared, why is it called point? Right? How do we know that it's a point? like graphically speaking, like what can like basically uh why is it a point if your r squared is zero? And likewise, why is why is it an imaginary circle if your r squared is less than zero? All right. Let me give you a spoiler. All right, let me give you a spoiler. When it comes to graphing, you need to know the length of your radius because the length of your radius will tell you how big or small your circle is. All right. So you need your r squared. Okay. So here's the thing, right? Earlier, right, it's negative one, right? So remember that the number on the right is your r squared. So r squared is equal to negative one. For you to find the length of your radius, all we need to do is find the r. So we need to square root both sides. So your r is equal to the square root of negative 1. Okay? Whatever you have here, like after you square root both sides, that is the length of your radius. However, if you're going to take a look, you have square root of negative 1. This is not a real number. Okay? Not a real number. No. This is a non-real number or imaginary. Okay? If you have a square root, okay, then you have a number that is negative and it is located inside the square root. That's not a real number anymore. It's imaginary. Okay? So point being, your r should be positive, or your r squared should be positive, not negative. Otherwise, you will have an imaginary result. And if you have an imaginary result, you cannot actually measure it in reality, which is why we need a real number value. Okay? Now, another one. What if, why is it that your, if your r squared is zero, it's a point? Okay? So in this case, your r squared is equal to is equal to zero. Okay, here you need to find the length of your radius, right? By finding r. So just square root both sides. You have r is equal to zero. So what does it mean? Okay, remember I said earlier when you find your r, which is by square rooting both sides, you know, there you will know like the measurement of your radius, right? But in here it's zero. So it implies that the length of your radius is non-existent. Basically, there's no radius at all. There's no radius. The only thing that exists only is the point of your center, like where is center located. You know, if the center is located and the radius is zero, then what happened? We only have the point where center is located, but there would be no radius. Hence, it exists just as a what? A point. So now you know, okay? Now you know why it will have a point if your r squared is equal to 0, and you will have an imaginary circle if your r squared is less than 0. So in here, you will now know if the general formula is a circle or not. Bottom line, your r squared should be greater than 0 for it to exist and identify as a circle. There, that answers the question. How would you know if the general formula of the circle is really a circle or not? You convert it to standard form, then the r squared should be greater than 0. All right? For it to be identified as a circle. That's it. All right? Now, these are some important information. These are important information. So you need to learn this. Okay. So let's now proceed to the next part, which is graphing. Okay. Let's graph. All right. So here, let's just say we have a given standard form, which is x squared plus y squared is equal to 1. And let's graph it. First, you must take a look your r squared. And remember, what's r squared? It's the number. Okay, here it's on the right side. So your r squared is equal to 1. Now you see it's greater than 0. So good. It exists and identifies as a circle. So let's find your r. So square root both sides. Your r is equal to 1. So that means the length of your radius is 1 unit long. That's it. Okay? Now let's find the center. Okay? Your center, the coordinates of center is H and K. So where is H and K located if you're going to ask me? Remember that in a standard form, okay, H is located beside X and K is located beside Y. All right? So where is H and K located? For H is located at X. For K is located at Y. However, take a look at this. There's no h and k for x. In fact, it's just x squared and y squared. So how are we going to know the center? So you see, the answer for that is 0, 0. Okay? Your h is 0, your k is 0. How do I know that? Okay? Because you see, x squared plus y squared is just basically the same as quantity x minus 0 squared plus quantity y minus 0 squared. Okay? They're just the same. Right? X squared is just the same as the square of x minus 0. Likewise, y squared is just the same as y minus 0. So for us to get the h, which is here, and for us to get the k, here's what we're going to do. All we need to do is we just change the sign here, right? It's negative 0. So it should be positive 0. All right? So here we have minus 0. It should be only positive 0. Actually, there's no such thing as negative or positive 0. But point being, we have to change the sign for us to get the center. All right? But here's the thing. Okay? We have only x squared, y squared. So there's no number beside x and number beside for y as well. Therefore, your h and k is 0. All right? So that's it. Okay, so now we found the radius and the center. What are we going to do? We graph it out. The first step here is for you to find the center. Where is center located? So according to your center, it's 0, 0. Where is 0, 0? So here, your x is 0 and your y is 0. That means it's located at the origin, or basically here, 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 where x axis and y axis intersects. Okay? This is the origin. So since your center has a coordinates of 0 and 0, therefore it implies that its center is at the origin. So here's your center. Okay, next. Now we have your r as 1 unit long, right? So here's what we're going to do. We will start at the center and we will count 1 unit to the right, to upward, leftward, and downward. Let me show you. Start from the center here. Count 1 unit to the right. So 0, 1. Okay, good. Go back to the center. Then count 1 unit upward. So 0, 1. That's it. Go back to the center again. Then count 1 unit to the left. 0, 1. All right. And lastly, go back to the center. Count 1 unit downward. So 0, 1. That's it. Then what are we going to do? We trace these points. And that's it. That's your circle. Right? That's it. It may not seem it's perfect or it really looks like an exact circle, but that's basically how you will graph circle here. And if you don't believe me, just search it in Google, like use Desmos graphing calculator and take a look how it is very similar to the drawing that I had. All right? So yeah, that is how you graph. Another example. this one. X minus 2, wait, here you go. X minus 2 squared plus y minus 3 squared is equal to 9. How to graph this? First and foremost, look at your r squared. Your r squared here is your 9. Okay, so let's square root both sides, okay? And here's the thing, okay? Since 9 is greater than 0, so it is in fact a circle, so it's a good. So now, yeah, we square root both sides to find the length of your radius, in which you will have 3 units long. So that is the length of your radius, right? Then let's find the center. So for your center, right, it's HK, okay? As I explained earlier, okay, again, in the standard formula, right, we have x minus h squared plus y minus k squared is equal to r squared. Okay. For you to get the coordinates of your center, which are h and k, all you need to do is that you have to change sign here. Okay. Change the sign here. Okay. So here, just make it what? What goes one? Make it h. What I'm trying to say here is that whatever the answer or the number you have here beside x and beside y, just change the sign. Okay? So that means, you see this? Negative 2, right? Your h is located here, okay? At beside x. So all you need to do is just change the sign. So you will have, instead of negative 2, positive 2. Let me write it here with the red color. Positive 2. And for the k, okay, it's beside y. And again, change the sign. So you will have plus 3, right? So here, we will have negative 3 instead. Okay? So yeah, that's it. That's it. Just change the sign. Now, if you're asking me why again, because again, if you're going to take a look at the formula, x minus h, if you're going to get the center, we only need h. Y minus k, we only need k. All right? So, if we're going to relate that here, okay, in that problem, right, we have x minus 2. So we're just going to leave it that way. Okay, we will leave it as x minus 2 squared. Okay, plus for the y, however, it's not minus 3, but rather it's plus 3, right? It's plus 3. So we can rewrite this as y minus negative 3 squared. Because again, in the formula, right, we have x minus h, y minus k, right? So here, what we're going to do is we're going to get the numbers here. So your h is 2, and your k here would be negative 3. So that is why you need to change the sign for you to get the coordinates of your center. Okay? So that's it. I already explained it in detail. All right, let's go. So let's graph it out. So here, um, let's locate first the center. All right, let me give some integers here because there's no given integers here. Let me just write it down. Just give me a just give me a second. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I'm gonna stop right there. 1, 2, 3, 4, 5. I think I'm gonna stop right there, okay? So the center here is 2, negative 3. So what does it mean? So if your center here is 2, negative 3, it implies that your x is 2, your y is negative 3. That means that from the center, okay, from the center, not center, from the origin, sorry, from the origin, which is here, the middle of the graph, you're going to count 2 units to the right. Since your x is 2, that means from the origin, you're going to count 2 units to the right. So starting from the origin, 0, 1, 2. Okay, here. Okay? Your x is 2. Now, next, your y is negative 3. So, that means that you're going to move 3 units downward. Why is it downward? Because it's negative. Otherwise, you're going to move it up. So, 0, 1, 2, 3. So, here, this is your, this is your center, right? That is how you find your center. Right, that's it. Now, let's go back. Your radius is 3 units long. So the same steps, okay? From the center, you're going to count 3 units to the right, upward, to the left, and downward. So start first from the center, count to the right. 3 units. 0, 1, 2, 3. Here. Going back to the center, count 3 units upwards. 0, 1, 2, 3. So it's here. Exactly. All right, it's here. All right. Go back to the center, count 3 units to the left, 0, 1, 2, 3, here. And go back to the center, count downward, 0, 1, 2, 3. That's it. Then we will trace these blue points, the outer ones, okay, the outer ones. From here to here to here to here, and that's it. There we go. That is your circle. Again, it may not be perfect, but it gave us an estimate of what the circle will look like. Okay, so that's it. Let's have some examples so that we can have some practice. All right, so let me just zoom out. We have this one. Okay, we have this one. Okay, so first and foremost, take a look again if 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 it really is a circle or not. So again, how would you know? Look at the number on the right because that is your r squared. So your r squared is equal to 6. Now, if you would notice, it's greater than 0. So therefore, it really is, in fact, circle. So we're good to go. Now let's find the length of your radius. So we will square root both sides. So here, the answer for that is square root of 6. Now, here's the thing. Square root of 6 is not actually a whole number. Just like for this one, 3 units, 1 unit. This one is square root of 6 units. So here's the thing. If you're going to use your calculator, it has multiple number of decimal values. Like there's like an infinite number of decimal values. So what are we going to do? Okay. So yes, that's the correct answer. It is in fact square root of 6. But if you're going to graph it, what are we going to do? We can just simply we can just simply round it off, to estimate the length of the radius. So it's either, in one decimal place or two decimal places. So for me, I would rather do it in two decimal places. So the radius here is approximately 2.45 units long. So that is how long is your radius. All right. So again, later I'm gonna explain how would you graph this one. Okay, I'm gonna explain later. Now let's find your center. So your center here again is HK. All right. So what to do if you're going to find HK? Just switch the signs. Look at x squared here. X squared is just x squared. There's no number beside x, just x squared. Not like the recent example we just solved, like x minus 2. No, it's just simply x squared. So what does it mean? Meaning it is 0. Remember, I explained this. If it's just x squared, there's no number beside x. It's just 0. However, for your y, it has a partner which is negative 5. So just change the sign. It will become positive 5. Okay, positive 5. Okay? So that's it. Now we will locate. So let me put some integers. Forgive me. I actually what do I call this one? I actually forget how to put these integers. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6. Okay. So first let's locate the center. So according here, your center is 0, 5. Your x is 0, your 5 is y. What does it mean? Meaning that for your x direction, you're not going to move. From left to right, you're not going to move. So that means, right, you're going to start at the center, right? Or center. origin, forgive me. You're going to start at the origin, then you're going to count right to the right or to the left, right? So here's the problem. Your x is 0. So that means you're not going to count to the right or to the left. Just like that. Just leave it like that. However, for your y, it's 5 units. And since it's positive, that means you're going to move 5 units upward. So 0, 1, 2, 3, 4, and 5. This is your center. Okay? That is your center. Okay. So now what? We will proceed to the radius. Now here your radius is 2.45 units. So again, this is just an estimate. So that means you don't really know how long is square root of 6 units, especially 2.45 units, you know? So let's just estimate. Okay, let's just estimate. Right? The radius, the length of its radius is 2.45. So that's basically almost close as 2.5, 2.5. 2.45 is close to 2.5, which is basically midway to 2 and 3. Basically, you will count 2 units. Okay, you count 2 units, then count zero point 0.5, basically midway. All right, let's start from here, okay, from the center. So we count from the center to the right, okay, 2.5 units. So 0, 1, 2, then plus zero point 0.5, which is between the 2 points. So here, this one, here, that's it, this one. All right, now let's do it upward. So 0, 1, 2, then midway to the next point. So here. Then go back to the center, then count to the left. 0, 1, 2, then midway to the next point. So it's here. And lastly, 0, 1, 2, then midway to the next point here. That's it. Then you trace the outer point. So like this. There we go. That's it. That is how you graph a circle. Okay, we're good. Okay, good. Let's have more examples. Okay, the more the merrier. All right, this one. This one is interesting because you see we have fraction. So how are we going to graph this one? All right. So first and foremost, start again to your r squared. Your r squared is 6. So since it is greater than 0, so it is a circle. So just square root both sides. Your length of the radius is square root of 6, okay, which is just the same as here, which is approximately 2.45 units long. Okay, that's it. So now we find the center. So your center here, again, HK. So for your H, we have 1/3, right? So change the sign, you will get negative 1/3. And as for your y squared, however, there's no partner. So just put 0. That's it. Then we now graph, right? Let's graph it now. And yeah, let me just put some integers, forgive me. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and yeah, 1, 2, 3, and 4. Okay, now let's take a look. Your center is 1/3. Now here's the problem. 1/3, if you're going to use your calculator, 1 divided by 3 is 0.33333333. It's infinitely a lot of number of 3. Or basically, let me show you. It's 0.333, 3, so on and so forth. There are a lot. So how would you graph it? How would you graph this one if you have this number? So just estimate. Okay? It does not need to be perfect. All you need is to what? To estimate it. Okay? Just estimate. All right? So let's do it this way. Let's make it zero point 0.3. Okay? Let me just erase this one. 0.3. So where is 0.3 located? Okay. 0.3 is midway to 0.5, like from 0 up to 1. The middle point of the middle number between 0 and 1 is 0.5. So here, the middle number of 0 and no, wait, no. Yeah, I think yeah, number between uh no, actually the middle number of 0 and 0.5 is actually 0.25, which is closer to 3. So point being, we're going to count 0.3 units. That is very, very close to 0. Okay? So now that we approximate our x as 0.3 and your y as 0, so that means we're going to move 0.3 units to the right. So it's very close to 0. So let's assume that it's here. Here, right? This one. This one. Then here's the thing. The thing here is that your y is 0. So that means you're not going to move up or down. So leave it be. That is your center. Now we're going to graph it. We're going to draw its radius. So it's 2.45 units, which is, again, by estimate, is just 2.5. So we will basically count 2 units to the right plus zero point 0.5. All right? We're just going to estimate it. Okay? So 0, let's just say this is 1 point, 2 point. Then midway, I think that would be wait, if this is the next point, then this one. This is the middle point, right? This one. Okay? So we will do the same thing, but we will go upward. Oh wait, let me change the color, forgive me. Here. That's it. Okay? Ah, fuck. Sorry for the language. Yeah, this one. Now let's go back to the center and move up. So 0, okay? 1, 2, then zero point 0.5, right? So it's here. Okay, let's do it to the left. Okay, 0. I think this is 1, 2, then zero point 0.5. I think it's just here. And lastly, we go down 0, 1, 2, then zero point 0.5. So it's here. So then we will trace them. That's it. Okay, that's it. Oh, there we go. So yeah, that's the graph of the circle. Okay, that's it. Again, this is just an estimate. All right. The reason why I include this in the uh, as a YouTube video tutorial, because there will be some moments that I believe that students will need to draw a circle even if it's not perfect. All right. There's a website for that. Desmos calculator, graphing calculator to be particular. It will help you to know what does it look like, you know, if you have this standard form of the circle. Okay. But what if there's no graphing calculator? So this is what you're going to do. All right. So now we will proceed to, I think, last exercise or last example, this one. Now, if you're going to take a look closely, this is not a standard form. This is a general form. So you know what to do. Convert it into standard form. Okay? So let's convert it first. So here we have x squared, x, y. So that means we're going to apply the second case. So what are the steps for second case? First step is take a look if there is a coefficient. Take a look at the coefficient of x squared and y squared. If the coefficient of x squared and y squared is 1, then we can basically proceed to the next step, which is grouping all terms that have variables, and the constant term will be put on the right. But for what do you call this one? For what do you call this one? What's that again? For the coefficient that is not 1, we have to divide both sides by that given coefficient. Okay? By the way, this is not x, it's actually 2x. Yeah, 2x. There we go. Right? There we go. So yeah. So since the coefficient of x squared and y squared is 1, so no need to divide both sides by 1 since it's 1. So what we're going to do is we're going to group them together, the terms that have variables, and the constant term will be put on the right side. So x squared plus y squared plus 2x plus 2y is equal to negative 2. Then on the left side, we're going to group all the x's and y's. So x squared plus 2x plus y squared plus 2y is equal to negative 2. Then here, we will do completing the square. Before we proceed, what to do if what you need for you to do completing the square? You need one, a squared what? A squared term where its coefficient is 1. And 2, it should have a partner. Okay? So for the x, we have x squared and the coefficient is 1. And we have the partner 2x. So we can do completing the square. For the y, we have y squared and the coefficient is 1. Okay, good. Then here we have a partner of y. So good. We can now do completing the square. So here's what we're going to do. Okay, so here for the x, what we're going to do is we're going to get the coefficient of x, which is 2. Then we're going to divide it by 2 and square it. So 2 divided by 2 is 1. Square it, you will have 1. We will do the same thing for the y. So the coefficient of your y is 2. So that means you're going to divide 2 by 2, then you're going to square it. 2 divided by 2 is 1. Square it will give you 1. So what does it mean if you have 1 as a result? Which is actually the same as for the x, you know? So that means you're going to have, okay, for the x, you will have plus 1 minus 1 beside 2x. And for the y, you will have plus 1 minus 1 besides 2y. So you will have x squared plus 2x. Then here you will have plus 1 minus 1. Here we have plus y squared plus 2y. Then here we have plus 1 minus 1. Then is equal to negative 2. Then the constant numbers that are negative, which are negative 1 and negative 1, you're going to put them on the right side. So as a result, you will have x squared plus 2x plus 1 plus y squared plus 2y plus 1 is equal to negative 2 plus 1 plus 1. All right. Before anything, let me check my battery of my laptop. Okay, we can still continue. Sorry, I'm just checking the battery of my laptop. Okay. So here we will simplify. So on the right side, we will add the constant numbers, which is easy. Negative 2 plus 1 is just 0. All right. Then these two polynomials, or trinomials rather, we're going to convert it into its squared binomial because these two are PST, or perfect square trinomials. So here for the x, we will have squared parentheses, put x here. So the number that you're going to put with x is the number that is the result of dividing 2 inside the squared parentheses here, right here. So 2 divided by 2 is 1, right? So you're going to put here 1. And since it's positive, so it's plus 1. Okay? Now, similarly, you will do here for the y. So square parenthesis, then y. Then, okay, what we're going to do is we're going to go back here in the process of completing the square. The result or the number you're going to put beside y is the result in dividing the number by 2 inside the square parenthesis. So 2 divided by 2 is 1. So you'll have what? Plus 1. That's it. So this is the result. Oh, wait, hold on. So this is what? Your standard form. Let me rewrite that x plus 1 squared. Now, here's the thing. Okay? Since we have the standard form, what are we going to do? Now we can get the radius and the center. Now, first things first, what are we going to do? Look at your r squared, which is 0. Your r squared is equal to 0. Okay, what do you think? Do you think this is a circle or not? The answer is it's not a circle. Right? Not a circle. Why? Because I told you earlier that if your r squared is equal to 0, then it's a point, not a circle. So, therefore, the graph here will not be 0. Not be 0, will not be circle anymore. Okay? You can find your r here, by square rooting both sides. You will have r is equal to 0 units, meaning the length of your radius is in fact 0. Okay? So now what are we going to do? Okay? Let's just find the center. So the center here, okay, all we need to do is find wait, hold on. All we need to do is find the h and k. And what to do to find the h and k? Just change their signs. For h, which is beside x, we have positive 1. Change the sign, negative 1. Okay? For the k, we have positive 1. Change the sign, negative 1. So this is the coordinates of your center. So let's graph it out, okay? So here, let me just put the integer. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So the center is once again negative 1, negative 1. So your x is negative 1 and your y is also negative 1. Okay? So let's locate where the center is. So since your x is negative 1, that means from the origin, which is at the middle of the graph, you're going to count 1 unit to the left. Why is it to the left? Because it's negative. So 0, 1 here. It's here. Then your y is negative 1. That means you're going to move 1 unit downward. And why is it downward? Because it's negative. So 0, 1. So this is your center. This one, okay? This one. Let me just erase the other red color. Now, since the radius is 0, so you can count 0 units, you know? You have no radius instead. So therefore, the graph is this one. That's the answer. Okay? You have a point here. Okay? And that is all, guys. All right? That is all for this video. Okay? So now at least you have the idea how to graph a given formula of a circle. Of course, it could either be standard or in this case, general formula. So just remember, okay, there are like some steps that you need to know when it comes to graphing a circle. Number one, make sure that it is in standard form. Remember, make sure that it is in standard form. Okay? Two, make sure that your r squared is greater than 0. Otherwise, the graph will not be circle. All right? That's it. Okay, you need these two parts. Okay, this not two parts. These two main points for you to know that it is a circle or not. All right? So that is all. The next video we're going to I think we're going to still talk about the graphing of circle, but bit of a challenge. All right? So see you guys soon. See you.